well at your home. I am Setu. I am the senior teacher of mathematics, Milestone School and College. We all know we are passing a very much tough day for this disease. In the meantime, Milestone School and College initiate a very great process for this online class. This would be very much helpful for you to continue your study at your home. You can look after the online CW and submit your SW in the comment. This is a very much continuous process for your study. So let's start today's class. My dear students of class 7, today our OCW number 19, which is from chapter 9, and we will discuss the general enunciation of Theorem-3 and its proof. In the last class we had discussed already theorem number 2, and today I am going to discuss theorem number 3. Let's start today's class. At the end of this lesson, you will be able to explain angle and side relations of a triangle, explain property of isosceles triangle with figure, proof theorem number 3. Let's see again. At the end of this lesson, you will be able to explain angle and side relation of triangle, explain property of isosceles triangle, proof theorem number 3. Review of previous lesson. My dear students, last class we had solved the theorem number 2. Now I am giving you 2 minutes to write down the general enunciation of theorem number 2. It would be help to make you better understanding for theorem number 3. That is the general enunciation of theorem number 2. If one side of a triangle is greater than another, the angle opposite to the greater side is greater than the angle opposite to the smaller side. This is the general enunciation of theorem number 2, and you have to write down again. So let's see again. My dear students, last class we had solved the theorem number 2. Now I am giving you 2 minutes to write down the general enunciation of theorem number 2, and theorem number 2, this is the general enunciation. If one side of a triangle is greater than another, the angle opposite to the greater side is greater than the angle opposite to the smaller side. Before going to start the proof of theorem number 3, we need to discuss some basic discussion that will help to prove theorem number 3, and you will understand better. At first, angle and side relations of a triangle. You can see this is the figure ABC, and the side we marked BC, A, AC, B, AB, C. That means this ABC is the marking side of AB, BC and AC. So from the figure, AB, BC and CA are three sides of the triangle. So you can see from the figure, AB, BC and CA are the three sides of the triangle. Now angle ABC equals to, in brief, angle B. That means in this figure, from this figure you can see angle ABC, that means this angle we can write in brief angle B. That means if you write angle ABC, it is also okay, or if you write only angle B like this, it is also okay. Same angle BCA, you can see from this figure angle BCA, in brief angle C. So this angle you can write in brief. So we can write angle BCA or we can write angle C, and angle CAB in brief angle A. So in angle CAB we can write in brief angle A. So my dear students, can you see one thing? Angle ABC in brief angle B, that means the middle one is our desired angle. Angle BCA in brief angle C, that means the middle one is our desired angle, and angle CAB in brief angle A, this middle one is our desired angle. So you will write the angle middle all the time. You will write the angle in the middle side. Okay. Now generally the sides opposite to angle ABC are expressed as ABC respectively. This is the general way. Okay, you can write another way also, no problem, but this is the general way. Generally the sides opposite to angle A, you can see in here is angle A and the opposite side is BC, so we can mark it A. After that angle B, in here angle B, the opposite side is AC and we can mark it B. And angle C, you can see the opposite sides is AB and we can mark it as C. So generally the side opposite to angle A, angle B and angle C are expressed as A, B, C respectively. Let's see again. Angle and side relations of a triangle, and from the figure you can see AB, BC and C are three sides of the triangle. Angle ABC in brief angle B, angle BCA in brief angle C and angle CAB in brief angle A. Generally the opposite sides to angle ABC are expressed as A, BC respectively. Therefore BC equals to A, CA equals to B and AB equals to C. So another brief discussion. Isosceles triangle, and we will learn now the property of isosceles triangle. If two sides of a triangle are equal, their opposite angles are also equal. So from the isosceles triangle ABC, so you can see the figure, this is the isosceles triangle ABC. These two sides are equal, AB equals to AC. That's why this triangle is the isosceles triangle, because we know in an isosceles triangle the two sides are equal. Two sides have same length, AB equals to BC. AB equals to BC is the same length, and you can see the mark. That's why this is the same length. Opposite angles of these sides are also equal. You can see AC and the opposite angle is angle B. AB, the opposite angle is angle C. Again I am saying, you can see AC, the opposite angle is angle B. You can see the cross mark. And AB, the opposite angle is angle C. You can see the cross mark. These two angles are equal. These two angles are equal. So angle ABC equals to angle ACB. So we can say this angle ABC and angle ACB are equal. That's why angle B and angle C are also equal. Let's see again. Isosceles triangle. If two sides of a triangle are equal, their opposite angles are also equal. So from the isosceles triangle ABC, you can see in the left side the figure is an isosceles triangle. Two sides have same length, AB equals to BC. Opposite angles of these sides are also equal. Therefore, angle ABC equals to angle. Now, theorem number 3, this is the general enunciation. If one angle of any triangle is greater than another, then the side opposite the greater angle is greater than the side opposite the smaller angle. Again I am saying, if one angle of any triangle is greater than another, then the side opposite the greater angle is greater than the side opposite the smaller angle. Now this is the figure. Angle ABC, you can see in here there is a triangle ABC. Now that is the particular enunciation of this theorem. Let triangle ABC be a triangle in which angle ABC greater than angle ACB. So we get from the general enunciation, this is the particular enunciation, that let triangle ABC be a triangle in which angle ABC greater than angle ACB. This is the language in here. If one angle of any triangle is greater than another, this is the one angle is greater than the another angle, then the side opposite the greater angle is greater than the side opposite the smaller angle. You can understand now. This is the ABC angle, that means angle B, and the opposite side is AC, and this is the angle ACB, and the opposite side is AB. So we have to prove that AC greater than AB. Again I am saying, let triangle ABC be a triangle in which angle ABC greater than angle ACB, because written in here, if one angle of any triangle is greater than another, then the side opposite the greater angle is greater than the side opposite the smaller angle. So greater side of the opposite angle, like angle B, the opposite side is AC, and angle C, the opposite side is AB. So we have to prove that AC greater than AB. Now the proof. This is the proof, and the first step is, if AC is not greater than AB, that means if we think AC is not greater than AB, it must be either equal or less than AB. That means if AC is not greater than AB, it must be either equal or less than AB. That is the thing. AC equals to AB or AC less than AB. So this is step number 2. If AC equals to AB, then angle ABC equals to angle ACB. In the last slide already you know about this. If AC equals to AB, AC equals to AB in isosceles triangle, then angle ABC equals to angle ACB. That means from the property of isosceles triangle, base angles of an isosceles triangle are equal. That is, we get from the property that if any triangle, the two sides are equal, then the opposite angles are also equal. That means if AC equals to AB, AC equals to AB, if we think the opposite angle of AC side is angle ABC equals to the opposite angle of AB side is angle ACB. That is, the base angles of an isosceles triangle are equal. But by the hypothesis angle ABC greater than angle ACB, this is not true. That means in the hypothesis we learned from the isosceles triangle that if AC equals to AB, the angle ABC greater than angle ACB. This is not true. Now step number 3, AC less than AB. If AC less than AB, that means if we think AC is less than AB, then angle ABC less than angle ACB. The angle opposite to a smaller side is smaller. Again I am saying you, AC less than AB, then angle ABC less than angle ACB. You can see from the figure, angle ABC less than angle ACB. The angle opposite to a smaller side is smaller. But by the hypothesis, angle ABC greater than angle ACB. So this is also not true. But we know angle ABC greater than angle ACB is not true. That's why we cannot write this. So what we have learned already, that if AC is not greater than AB, it must be either equal or less than AB. That means we are trying to prove that this is equal or less than. But when we are trying to prove if AC equals to AB, then angle ABC equals to ACB, this is not true, because this is the hypothesis rules. This is not true. Again, AC less than AB, then angle ABC less than angle ACB, the angle opposite to a smaller side is smaller. This is also not true, because already we have learned the last 2 slides. These are the not rules of this triangle. Therefore we can write AC not equals to AB and AC less equals to AB. That means these are the right things. Now we can write AC greater than AB, because already we are trying to prove that AC equals to AB or AC less than AB, but that is not the true. That's why you can write AC greater than AB. So this is our desired proved. So my dear students, let's see again theorem number 3. This is the general enunciation. If one angle of any triangle is greater than another, then the side opposite the greater angle is greater than the side opposite the smaller angle. This is the particular enunciation. Let triangle ABC be a triangle in which angle ABC greater than angle ACB. It is required to prove that AC greater than AB. So this is the proof. If AC is not greater than AB, it must be either equal or less than AB. That is, AC equals to AB or AC less than AB. The number 2 step, if AC equals to AB, then angle ABC equals to angle ACB. But the hypothesis of angle ABC greater than angle ACB, this is not true. This is number 3, AC less than AB, then angle ABC less than angle ACB. But by the hypothesis, angle ABC greater than angle ACB, so this is also not true. So we can write AC not equals to AB or AC not less than AB. So this is the rest of the thing that we get, AC greater than AB. That is the proved. Summary of today's lesson. We have learned today the general enunciation of theorem number 3, and this is important for you. If one angle of any triangle is greater than another, then the side opposite the greater angle is greater than the side opposite the smaller angle. And this general enunciation, you will need to prove another theorem of the next chapters. That's why this general enunciation and this theorem is very, very important for you, my dear students. Please listen carefully. We have learned today how to prove theorem number 3, and this is the summary of today's lesson. So again I am saying, we have learned today the general enunciation of theorem number 3 and the proof of theorem number. So my dear students, our OSW number today is 19, and chapter 9, from chapter 9 you have to do theorem number 3. Write down general enunciation, particular enunciation and proof. I think all you enjoyed the class and you understood everything very well, and we will meet again with another topics in another class. Stay home, stay safe, be well. Assalamu alaikum.